So we've been going off on a sort of a factoring binge right now, and we're just talking about the different types of factoring techniques that we have, specifically polynomials, right? So we've already talked about how to factor just numbers in general, anything from the rational number set with prime factorization, right? We've talked about the greatest common factor, we've talked about the difference of squares, we've talked about simple trinomial factoring, and we've talked about complex trinomial factoring. We've got two more factoring techniques to talk about. One of them is the quadratic formula, and the other one is synthetic division. Now these two, kick it up a notch. They give us a lot more power. So the first one we're going to talk about is the quadratic formula. And the quadratic formula, it's literally, it's the formula that I'm going to take to the grave with me. It's the only formula I remembered years after high school. There was a period in my life where I didn't use mathematics that much, and when I started going back into mathematics, it was the only formula that came to me automatically. Okay, more so than even the area of a circle, or the circumference of a circle, or area of a triangle. Okay, this formula, a lot of people, it freaks people out. It looks horrendous, but it's really simple. All it is just you're taking numbers from your quadratic equation and just plugging them into the coefficient, and what it does, it gives you the factors, right? It gives you the x-intercepts, your roots, right? And the formula is basically, you should say it, it's x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a, okay? It should roll off your tongue. You should dream about this or have nightmares about this, okay? This is the formula. X is equal to negative b plus or minus b squared minus a square root of b squared minus 4ac over 2a. Okay. All those letters you see there, those are your a, b, and c, your coefficients and your constant from the quadratic formula, right? Or any from the quadratic equation, right? Or quadratic expression or quadratic function, right? And your x there represents your x-intercepts, right? Your roots. So the way it works is you have your quadratic equation, right? Your quadratic function, basically. So I use the function notation, right? So you have a quadratic function, and if this is a quadratic equation where you're trying to solve a quadratic equation, all you do, this f of x disappears, and all you do is just say equals to 0. And what that is, the equals 0, the 0 represents your y coordinate, basically, where y is 0, and that's where you're intersecting the x-axis, right? So a, b, and c in the quadratic formula are just your a, b, and c from your quadratic function, from your quadratic equation. Okay. So whenever you're given a function like this, an equation like this, you put it in this form, and we've talked about this, right? You got to put it in the right order, right? Highest x first, and then descending x values. And this is basically a trinomial, right? So quadratic formula is used for quadratic equations, but it's a little bit more than that, because you can use it for equations, functions that are ax to the power of 4, 6, 8, where this power, the x squared power, has to be double this power, right? So you could have a function in the following form. And I really quickly changed the minus c to plus c, because the notation is basically plus c. So for your quadratic formula, for your quadratic equation, you can have ax2 plus bxn plus c, where n is the element of the natural numbers, right? So in here, where you got bxn, the n can go 1, 2, 3, 4, all the way up to infinity, and the x power in front, ax2n, basically means that has to be double this guy. So what you end up with is the 2n basically means that this power here always is going to be positive, right? That's these types of equations you can use the quadratic formula for, and we're going to talk about these things, right? And basically what we're going to do examples where we're given equations like this, and we're going to solve for them and find your x-intercepts and your roots, okay? Now, one thing to keep in mind, and we're going to talk about the quadratic formula a lot more when we get into factoring polynomials, but one thing to keep in mind, inside the root symbol, this guy here, that guy is called a discriminant, okay? So what we have here is b squared minus 4ac. This thing is referred to as the discriminant, okay? And the discriminant in mathematics is, it gives us information regarding the nature of the roots for a polynomial function or polynomial equation, okay? Right now, we're just going to talk about b squared minus 4ac. There are discriminants for, cubic functions, quartic functions, or whatever, right? It's just a general term, and it refers to, for the quadratic formula, it refers to b squared minus 4ac. And this thing, whatever is inside the root symbol, tells us something about your roots, your factors, right? For quadratic functions, for the quadratic formula, there's three things that can happen with b squared minus 4ac. I'm just going to lay it out here, and we're going to talk a lot more about this, but just to give you a teaser, it basically looks like this. Now, if the discriminant, I'm just going to use the symbol d. There are other symbols that people use, right? That's used all around. One of them is, I think, it's the triangle. But anyway, we're just going to use d as representing the discriminant, right? So if the discriminant is greater than 0, basically it means it's a positive number, right? You could take the square root of a positive number, and as we've talked about, the square root of anything is plus or minus. That's where the plus and minus is coming from in the quadratic formula, right? So if d is greater than 0, then we're going to have a plus and minus, so there's going to be two real roots, right? Because we're going to have x is equal to negative b plus the square root of whatever that number is, and x is divided by 2a, and x is equal to negative b minus the square root of what that number is over 2a, right? So that's two different roots, right? And those are two different x-intercepts. So it's telling us that the function, the parabola, crosses the x-axis twice. If the discriminant is equal to 0, so if inside the root symbol here is 0, then what happens is square root of 0 is 0, so all we're going to have is one real root. There's different terminology for this. They call it two identical roots, one real root, right? So what happens is, as soon as d is equal to 0, the discriminant inside the root symbol is equal to 0, then all you get is x is equal to negative b over 2a. So that means your parabola crosses the x-axis, or touches the x-axis. It doesn't cross it. It touches the x-axis once. So if you have your Cartesian coordinate system like this, the parabola comes down, touches it, and goes up, or parabola comes up and touches it and goes up, right? When d is greater than 0, the parabola crosses the x-axis, or goes down like this, right? If the discriminant is less than 0, it means it's negative, right? Anything less than 0 is negative. And you can't take the square root of a negative number in the real number realm where we're working right now, right? You can't take the square root of a negative number. Then what happens is your parabola doesn't touch or cross the x-axis. So if you have your Cartesian coordinate system, your parabola either is formed above it or formed below it, and it doesn't hit the x-axis, right? And this is called the discriminant. It gives us a lot of information about the function, and the nature of the function, the nature of the roots, basically, right? And we're going to talk a lot more about this when we start graphing polynomials. Right now, what we're concerned about is using the formula to solve quadratic functions or to factor quadratic equations, right? Or anything in this form, basically. And we're going to do one like this. We're going to do 2 or 3 questions, examples like this, and we're going to do one like this. And later on, when we get into factoring polynomials, we're actually going to derive this formula. And this formula is just basically, all it is messing around with the equal sign, and there's something called completing the square. So what we're going to do is use completing the square and derive this formula when we get into graphing polynomials, graphing quadratic functions, which is super important, right? It's a huge section in my area anyway, in grade 11 mathematics. And we're going to touch on this right now. We're just going to solve equations, find the roots, find the factors, find the x-intercepts, and then once we've learned all our different factoring techniques, we're going to go into the polynomial section and start graphing some of these polynomials.